So here's the first tutorial in algebra. Algebra is really, really important for maths, and it's really, really important for programming. You have to be able to understand how to manipulate algebra, and my focus in these tutorials is going to be to try to explain why things work, so you've got a really good understanding of the basics. And that's why I'm starting with some stuff that you may find pretty easy. So the first question is, what is algebra? And algebra is about generalization in many ways. If we come up with a sum like, I don't know, 1 plus 4 equals 5, I can't extrapolate any rules from that because it's all very specific. We're dealing with the number 1 and we're dealing with the number 4. And in order to make it general, what we have to do is say, look, here's a way in which something could relate to any number. And the way we do that is by referring to a number by a symbol or a letter instead. For example, and this is the one that people use most of all, x. You'll notice that I've written x as a curly x. The reason for that is to avoid confusion with a multiplication sign. It doesn't have to be a letter. It could be a Greek letter. We quite often use alpha, beta, and all sorts of other things there. And indeed, it could be anything as long as everyone understands your convention. Could be a box or a triangle. Anything as long as everyone knows this is representing a number. Okay, so we're doing this so that the letter can represent any number. Let's look at some of the basics about working with these numbers and these letters. The first convention really is, if you're going to use two letters, you've deliberately done that to say, look, there's A plus B, but A isn't necessarily the same as B. It could be on occasions, but we're deliberately now allowing two variables effectively. They could be different things. And for that reason, I can't really simplify this generally anymore. If I make it specific, like we did before, I can add it up. But generally, add any two numbers together, any two numbers, remember, A or B, I can't come up with a rule that says that's always equal to whatever. But if I'm adding the same number to itself, I can make a general rule that I'm going to get the answer, which is 2 times that number. Okay? And in maths, because we're quite lazy in terms of writing things down, we tend to lose the multiplication sign and just write 2a to mean 2 times a. Which leads us to other more complex strings of algebra. We could have a plus 3b minus 4c plus 7a minus 10b. For example, we look at the a and the 3b. We can't do anything with those. But what we can do is something with the a and the 7a. A plus 7a is 8a. I've got one lot of a there and 7 lots of a there. Therefore, the answer must be 8 lots of a. With the b's, it's similar. I've got 3b here and I've got minus 10b here. Well, 3 minus 10 gives me minus 7 lots of b. And with the c, I've got a minus 4 c's here. There's no other c's, so I can't simplify that anymore. So I'm going to get minus 4c. And that's the simplest way in which we can write this expression. Now, the other thing to think about is multiples of two numbers, which we haven't covered yet. So I'm going to draw a quick line under that. I can write down, you notice here I've written 2a to mean 2 times a. I could write ab, which means a times b. I could write a squared. Now, I haven't done a tutorial yet on squares, but I'm hoping that you've watched the tutorial, which I haven't done yet. It means a times a. And we can have cubes, we could have b cubed, we could have powers of negative, we could have a to the power minus 4, we can have a power of a quotient, a to the power 3 on 2. All of these kind of things. you can't multiply. No, I'm going to do this bit again. You can't add together a squared and a. They are different numbers. That does not equal, for example, 2a squared a, or anything like that. Any combination you might think of, you just can't do it. And so if I come up with, let me create some space here. If I come up with an expression similar to this one here, this ain't going to be perfect first time. Okay. If I come up with an expression like this, a squared plus a plus 3b cubed minus 7a squared plus ab equals, there's nothing there that I can add to anything else apart from these, which are identical. Okay, I can't simplify that anymore. So these two, a squared minus 7a squared, is going to give me minus 6a squared. And then in terms of just algebra, everything else is just going to remain the same. So that's how you add algebra, or add algebraic terms together. I'm going to do a little bit now on multiplication, which is a bit easier. You can simplify a lot more with multiplication. Wish this rubber were a bit bigger, but I think I'm on max. Okay, this is I like the fact that these tutorials are so informal and a bit rubbish. Okay, there we go. That'll do. Okay, so I'm going to talk now about multiplying. A times B, we've already spoken about. You can write more simply, although we haven't actually done anything, as AB. If I come up with a term like, I don't know, a to the 5 divided by a squared b squared. Let's look at that one. Well, first of all, I don't like using this sign for divided, really. I prefer to write it like this. It means the same thing. Okay? The second thing, if you see my fractions video, you'll know that you can cancel down fractions because they're equivalent. And by cancelling down, I mean dividing the top and bottom by the same thing. If we look at this a to the 5 there, we know that that means a times a times a times a times a. Okay? And this a squared means a times a. So what I can do is actually cancel down that a with that a and that a with that a, which is going to leave me with 1, 2, 3, a cubed on the top. That a squared is gone, b squared on the bottom, which gives us kind of a general rule when dealing with division of indices. We're dealing with indices here, in as much that a over m divided by a over n equals a to the m minus n. Okay, and I'm going to remove some of this stuff again in this shambolic, amateurish kind of way. Okay, because I'm going to come up with another rule now. And here's your second rule of working with indices and algebra. Okay, your second rule is if I've got a squared times a cubed, I can split these down to a times a being a squared times a times a times a. Whoopsie. Okay, and now you can see that actually that's the same thing as a to the 5. So our second general rule, and I'm going to run out of space here because I've got a third one yet, is that a to the m times, look, I'm introducing a dot here to mean times. If you write just a dot in maths, it means times as well, is a to the m plus n. You see I've just added the indices here. The 2 and the 3 makes the 5, and hopefully you understand where that comes from. Okay, so here's my final rule in terms of algebra and working with indices, and that is, what does a squared cubed mean? Well, a squared cubed must mean that I've got a squared multiplied by itself 3 times. Okay, but from this rule that we've learnt here, if you're multiplying, obviously the a has got to be the same. You can just add these. So this is a to the 6. Okay, and here's our final rule in indices and algebra. Okay, a to the m to the power of n is a to the power mn, where mn means m times n, as we've seen before. Okay, so that's the end of the basics in algebra, and in the next lesson I'm going to start looking at manipulating algebra to solve linear equations. If you enjoyed this tutorial, don't forget to like, comment, subscribe. If you put your questions below, I'll do my best to get back to you as soon as possible.